Welcome to It's Good to Be Smart. I'm your host, Dr. Dave Mulder. I love to learn new things, and I hope you do too, because it's good to be smart. Today, we're diving into ways we can mix up matter, because matter can be combined in many different ways. Whether it's a physical mixture or a chemical reaction, matter's always surprising us with how it behaves. Let's get started. First things first, let's recall what matter is. Matter's anything that takes up space and has mass. Matter can exist as an element, a compound, or a mixture. An element is a pure substance made of just one type of atom. Think of gold or silver or oxygen. These are all elements. They're pure substances. Gold is made up of just gold atoms. Oxygen is made up of just oxygen atoms. You get the idea? A compound is what happens when two or more elements chemically bond together. Water, for example, is a compound made of two hydrogen atoms bonded to one hydrogen atom. The key is that those different kinds of atoms are chemically combined. Compounds have fixed ratios, which is why every water molecule is the same, two hydrogens connected to one oxygen, every single time. Now, mixtures are where things get really interesting. A mixture is a physical combination of two or more substances where each substance keeps its own properties. Unlike compounds, mixtures don't have fixed ratios, and they can usually be separated back into their individual parts. The key thing is that it's a physical combination. This is different from a chemical reaction, okay? We'll talk more about reactions in just a minute, but let's start by looking a little closer at mixtures to try to figure out what happens when we mix up matter. And hopefully we can prevent ourselves from getting too mixed up in the process. Mixtures come in two main types, homogeneous and heterogeneous. A homogeneous mixture is uniform throughout. That means you can't see the different parts because they're evenly distributed and mixed up smoothly. For example, when you dissolve sugar into water, you get a homogeneous mixture, or what scientists call a solution. In a solution, the substance doing the dissolving is the solvent, in this case water, and the substance being dissolved is the solute, the sugar. The solvent dissolves the solute, creating the solution, which is a smooth distribution of the mixed up substances. The particles of the solvent and the solute are both tiny, so they stay uniformly mixed. Maybe it'll help you to say it this way: solutions are smooth. On the other hand, a heterogeneous mixture is not uniform. In a heterogeneous mixture, you can see the different parts, like in a bag of trail mix. Each piece of trail mix is distinct, and they're not evenly distributed throughout the mixture. In other words, if you grab a handful of trail mix, you might get a different combination of raisins, peanuts, and candy pieces every time. Maybe one handful it's all raisins with just one peanut, and the next handful is all peanuts with just one raisin. It's not uniform. Another example of a heterogeneous mixture is called a suspension, like muddy water. In a suspension, there are some parts that are made up of larger particles and some parts that are made up of smaller particles. If you let muddy water sit for a while, the dirt eventually settles to the bottom because the big particles of dirt settle from where they're mixed in to the much smaller particles of water. Remember this: suspensions will settle. There's also a middle ground between solutions and suspensions called a colloid. Colloids have particles that are larger than in a solution, but small enough to stay suspended without settling. Whipped cream and milk are great examples of colloids. So is fog, droplets of water suspended in the air that don't settle out. The fact that colloids exist is a good reminder of how wonderfully weird creation is, that we can't always easily sort things into this or that categories. But let's keep in mind, all these mixtures are physical combinations of multiple kinds of matter, and if we can mix them up, we should be able to unmix them too. One of the coolest things about mixtures is that you can separate them using physical methods. For example, you can use filtration to separate a solid from a liquid. Imagine you're brewing coffee. The coffee grounds stay in the filter while the liquid coffee passes right through. Another method is evaporation. If you dissolve salt into water, you'll get a solution called salt water. And then, if you let the water evaporate out of that salty solution, the salt crystals are left behind. And this is how salt is often harvested from seawater. There's also a process called distillation, which separates substances based on their boiling points. This method is used to purify water or even make essential oils from plants. Okay, so far we've been talking about making mixtures by stirring together two or more substances in ways that mix them together, but the substances themselves don't really change. In a sugar water solution, there's sugar dissolved through the water, but the sugar is still sugar and the water is still water. They're just smoothly mixed through each other. But what happens when matter combines in a way that changes its very nature? Well, that's where chemical reactions come in. A chemical reaction occurs when substances combine or break apart to form new substances with new properties. And unlike mixtures, you can't separate the original substances using physical methods. For example, if you mix vinegar and baking soda, you get a chemical reaction that produces carbon dioxide gas. The fizzing you see is the evidence of a new substance being created. Chemical reactions are all around us. Rust forming on iron is a reaction between iron and oxygen. Cooking is full of chemical reactions too. When you bake bread, the yeast produces carbon dioxide, which makes the bread rise. The thing to remember about chemical reactions, though, is that they're not really mixtures, even though you might think of starting the reaction as mixing two substances together. Because they result in new substances being formed, like the carbon dioxide fizzing out of the baking soda and vinegar, these chemical changes can't be easily undone. The products of a reaction are uniquely different substances than the reactants you start with. Before we wrap up, here are a few fascinating facts about mixtures. Did you know that the air we breathe is a mixture? It's made up of about 78% nitrogen, 21% oxygen, and small amounts of other gases like carbon dioxide and argon. Alloys like steel and bronze are homogeneous mixtures of metals. Steel is a mixture of iron and carbon, while bronze is made of copper and tin. And here's a weird fact. Some complex mixtures can be mixtures of mixtures. For example, the ocean is both a solution and a suspension. It's a solution because salt is dissolved in the water, but it's also a suspension because sand and other particles can be suspended in that water and can settle out of it. After all this talk about mixtures, I hope you aren't feeling too mixed up yourself. Just remember, physical mixtures can usually be reversed through some sort of physical process like filtration or evaporation or even just sorting things out from a jumbled mixture like trail mix. Chemical reactions, on the other hand, well, then we're talking about making new substances by rearranging the particles. So those are a lot harder to undo, and they can't be physically undone in the way mixtures of substances can. Thanks for joining me for this episode. Nice work leveling up your brain power today. Remember, smart isn't something you are, it's something we become as we're learning. So keep listening, keep learning, and keep getting smarter every day. It's Good to Be Smart is created and produced by me, Dr. Dave Mulder, with the support of the National Science Foundation through a Robert Noyce educational grant. Subscribe to this feed so you'll never miss an episode, and check out our home on the web, goodtobesmart.com. And until next time, keep asking questions, stay curious, and keep learning, because it's good to be smart.